Hi, my name is Harshal Dev
And my name is Ankit Yadav.
and we'll be presenting our BTP work. So let's first go through the problem statement. Intestinal tuberculosis is a form of tuberculosis that can affect the digestive system, specifically the intestines, whereas Crohn's disease is a chronic inflammatory bowel disease that can affect any part of the digestive tract. Now, intestinal tuberculosis may mimic Crohn's disease, and hence it can be overlooked by the doctors where TB is not endemic. So this can lead to a lot of high rate of misdiagnosis, and the patient can suffer a lot because of it. Even though intestinal tuberculosis shares many aspects with Crohn's disease, but both of these are treated very differently. So, given the high rate of misdiagnosis, we had to develop a machine learning model to accurately predict between the intestinal tuberculosis and Crohn's disease, with a subproblem that even when the data is incomplete or has missing values. So as a part of the EDA, we realized that we have 999 data samples and with 30 features, and all the features are categorical in nature. And as a part of a data preprocessing, we label encoded the categorical features and applied chi-square test. The reason we did chi-square test is that the input and the output were both categorical in nature, and as can be seen in this graph, we kept all the features that had a threshold value less than 0.5, and then we did visualization using TSNE and realized that the dataset is not separable as seen in this graph. And then we did the oversampling of the dataset to avoid any kind of bias that might creep in the machine learning model. So we applied these models, SVM, MLP, random forest, and Ranger, and we got the best result from the random forest. That is an approximately accuracy of 90%. But the recall value is more important in this aspect, because since this is a healthcare problem, because false negatives can have a serious consequence, therefore recalls is considered more than accuracy. And we can see that that among all the models, four models, that random forest has the highest recall value.
Okay, so the next thing is to develop a Bayesian network model on our dataset. And why there is a need for it? It is because there is an app developed from another team, and the user of the application, that are doctors from AIMS, can sometimes don't give the inputs like hemoglobin. And to tackle this problem of missing inputs, our advisor Dr. Taf Pritish advised us to develop a Bayesian network model, and it can incorporate the missing inputs too. For developing the Bayesian network model, we have used the in-house tool Visor developed by TabLab. It is an open source R-based tool which is used for multiple things like data preprocessing, generation of relationships, creating causal graphical models using graph neural networks, and Bayesian networks. Now for generating the Bayesian network using Visor, these are the parameters used. So here is the algorithm: hill climbing and network score Akine information criteria. Parameter fitting, we used Bayesian parameter estimation, and we don't have any blacklisting. And these are more parameters listed below. Now we can vary these parameters to generate different kind of graphs, but these are the best parameters till now. Let's see the Bayesian network graph. So this is the Bayesian network graph we created. The final diagnosis is our predictive feature, and it is dependent upon 11 more features if we take it till the one neighbor only. For simplicity and creating a basic Bayesian network, for now we have taken nodes till one neighbor only. That is, we are ignoring the nodes after first neighbor. For example, if we take the relationship between final diagnosis and diarrhea, the diarrhea is further extending till weight loss and fever. But if we take only one neighbor, we only took final diagnosis is dependent upon diarrhea and neglect any weight loss or fever. Now, as it is seen, more arrows are coming out of the final diagnosis compared to the incoming arrows. So it does not matter that bleeding PR or diarrhea is dependent on the final diagnosis. So it doesn't mean that bleeding PR or diarrhea is dependent on final diagnosis. It's just that it is a non-causal model. The direction does not depict any dependency. To make it causal model, we can introduce model blacklist edges. Now, as discussed, Bayesian network has an advantage to tackle the missing inputs. This is how it tackles the problem of missing inputs. So we in this screenshot we can see that we have three inputs, that are pulmonary symptoms, gender, com sign, and the probability of the person having tuberculosis is shown below. Now in this screenshot, we have removed the third parameter, that is COMSIGN, and still it is working and the probabilities are adjusted accordingly. The accuracy achieved using Bayesian network is 82.5%, precision is 81.77, recall is 80.92, and F1 score is 80.28.
Now let's understand the challenges that we face in the project. So the first problem was that we had to understand Bayesian network models, and then we had to also get familiar with the in-house tool, that is Visor. Since it is an in-house tool, there was no documentation available as such to help us when we were getting stuck, right? And then we also had to calculate the CPD, that is the cumulative probability distribution, for the from based on the graph that we just got from the Visor. And the future work, the future work for the project is that we'll be fine tuning the Bayesian model to get more recall and accuracy, and also we're in the process of paper writing. Along with it, we are also incorporating the model in the application. Thank you.